that this is the last lesson for chapter 9. So we're covering the last type of transformation today. And that means tomorrow and Friday are review days, and your test is falling next week Tuesday since we don't have school Monday. So just keep that in mind. But today for dilations, and today's lesson should be pretty short, so I'm also going to pass back your quizzes. Go through those. You can keep those. I had them graded, but I just got them entered this morning. So you'll get those back. If you didn't look at your grade, you'll be able to see it. So dilations, these are transformations that change the size of a figure. So this is a transformation that will change the size of a figure. So by changing the size, we either describe it as the figure can be enlarged or it can be reduced. So this is the terminology. You'll be identifying whether a dilation is an enlargement or a reduction. So then in the very first lesson, I know we've reviewed it a few times. What is an isometry? What does that mean? It's what? When it doesn't change what? The shape or size. So yes, an isometry is a transformation that will not change the shape or size. So what are transformations that don't change shape or size? Translations, reflections, rotations. Yes, and then those are the three we've covered, and then we had symmetry, but that's not really a transformation. That's a property. So the question is a dilation then considered an isometry? No, because directly in the definition, we say it changes the size. So this is no, and it doesn't say why, but if you want to write why so you understand why it's no. No, because it changes the size of the figure. So the new figure, so maybe smaller or larger than the original by a scale factor. So we measure the dilation by its scale factor. This is similar. We did enlargements and reductions in our proportions unit. So it's similar to that where you're kind of saying is it enlargement or reduction, finding that scale factor or using the scale factor to graph a dilation. The new figure and the original figure are similar. So up here, isometry is when the new and original figures are congruent. Here they are similar, so they have the same shape still, but they are not the same size. So remembering from our similarity unit what similar means. And dilations are completed with respect to a center point and a scale factor. So then it gives us if point P just has coordinates x, y, if that is the pre-image of a dilation centered at the origin with a scale factor of r, then the image is P prime, and this is how you find the image. So you go from x, y, scale factor is r, both of the coordinates in the ordered pair are just multiplied by that scale factor, and that's how you would graph a dilation. Scale factor, here's the formula for it. It is the ratio of the image length to the pre-image length. And again, the image is the new figure, pre-image is the original. So example 1, these are very straightforward. You are just stating what type of dilation it is it an enlargement or a reduction, and then finding the scale factor. In this one, it does say from B to B prime. Notice these both say B. This first one here that you see, this should be B prime. So by looking at that, would you say that is an enlargement or a reduction? Reduction. So you're going from this triangle, because that has a vertex of B, down to this smaller one. This is the new one here. So this is a reduction. And so the scale factor then, so I know that the 4 and the 6 here, these are not lengths of the side of any of the sides of that triangle, but you can still use those lengths to get your scale factor. The only thing is, well, I'll say that. So we have this length from, this would be our point, our center point. That's where the dilation is happening from. So from there to this vertex for the image, because again, you want your image length to be on top, that is a length of 4 over the length from the point to the pre-image. Careful, it's not 6. That length is 10. That's the 4 plus the 6. So it would be 4 over 10, which can be simplified to 2/5. Okay, and then in example 2, same idea. Here we have from Q to Q prime. So again, enlargement or reduction. Enlargement or reduction. Did the figure get bigger or smaller? Bigger, thank you. I don't know if you're looking at me wondering why I'm asking because it's obvious, or you don't know what I'm talking about. So it needs some sort of clue. So enlargement, and part of it is remembering notation also, knowing which one represents the pre-image and the image. So the bigger one is our image. So then how would we set up this scale factor? What would the ratio be, Ethan? The 15 over 5, yes. So 15 is to the image, 5 is the pre-image, and that simplifies just to 3. So that means our image is 3 times as big as the pre-image. Looking at scale factors to make sense of your answer. When you have a reduction, your scale factor should be a number that is smaller than 1. Bless you. So this is a way to, like, in case you have these switched around, say you said it was a reduction, then you had 5 over 2 here, which would be 2.5. That's your clue that you need to switch it, because if you're saying it's a reduction, that has to be smaller than 1. Likewise, if it's an enlargement, your scale factor should be larger than 1. So if you said it's an enlargement and then gave me 1/3 as the scale factor, what you're saying is your new figure should be 1/3 of the size, which would actually make it a reduction. So that should be an enlargement. So that's your clue if you have it switched around, kind of making sense of that ratio. All right, and then the last part then is graphing dilations. So as we already talked about, when you're in a coordinate plane, and these will all have a center, the dilations center point will be at the origin. But to find the coordinates of an image after a dilation centered at the origin, we multiply both the x and y coordinates by the scale factor of r, whatever your r value is. So it doesn't say this, but we've been doing this for all of the other transformations. I'd like you to graph the pre-image and graph the dilation so you can really see what's happening. So I'm going to graph this quadrilateral we have here, EFGH. Make sure you label. And actually, when you graph this, it is a rectangle. And then we are given the dilation of 0.5, meaning our image should be half the size. But again, it's in relation to the center point being the origin. So I would calculate your vertices of your image, meaning I'm multiplying all of my coordinates by 1/2, which is the same as dividing them by 2. So E prime is going to end up being -1, -1. F prime will be -1, 2. G prime will be 1, 2. H prime will be 1, -1. And then I plot and label those. And because it's in relation to the origin, you just see that the vertices kind of went inwards towards where that origin is, but you have a rectangle that is half the size. So if you are ending up with, you see your R is smaller than 1 and you ended up with an enlargement, something went wrong. Right, you can go ahead and graph number 2 as well. That one you can do without me, and then I'll show it. Those are dilations. So I'm going to pass out your assignment, but like I said, I'm also going to be passing back your quizzes. So go ahead and do that example 2 if you haven't already. Yes. I know. When you're done, not all of you were done when I walked around, so you can check. Remember, you do multiply by R. The only reason I was dividing in the first one is multiplying by 1/2 is the same as dividing by 2. So here you'd multiply all of your coordinates by 2, so your triangle should be twice as large.